Audio test. Looks like it's working. Hey, off again. So I got a Discord set up in case people. I've had a couple choppers now come by and stuff like that, and maybe it'd be more fun if we could connect off stream about coding questions or Japan stuff. So I'll put that up. I might add a link to the top. I should also copy this to the. See if I can. No, there is a message to the chat. There you go. Easier than trying to like screen capture them. Can't tell if the. Okay, good. Okay, so I'm gonna do another coding 12 unless somebody shows up, wants to chat. What is good? Let's see what valid number is. Given a string as returned as is a valid number, example, are valid numbers. Yeah. Interesting. And there's built-in functions for this in JavaScript, but maybe they don't want us to use that. Okay. Maybe. Maybe no interest. Window substring. Given two strings, return the minimum window substring S such that every character T, including duplicates, is included in the window. Oh, interesting. So we have to find the smallest substring we can find that has every possible character. I feel like this one is interesting. Can you find an algorithm that runs in M plus N? I feel like we should just jump straight to that. Oh, okay, this one looks fun enough. Okay, so let me just read the whole thing. Given two substrings S and T of length M and N, respectively, turn the minimum window substring of S such that every character T, including duplicates, is included in the window. There's no such substring, return the empty string. The test case will be generated such that the answer is unique. There's only one possible. There might be duplicate T's, but there might not be duplicate, like, there's not going to be duplicates. Strings. We have to output what that string is. Got it. From the minimum window substring B, A, and C includes A, B, and C from the string. The entire string is S in the minimum window. So it's the whole thing. And both A's have to be included in the window since the largest window has only one A. And I'm assuming if there was like this was flipped, it was AA, TA, then the substring, well, actually that would have violated this, I guess, but okay, let's see if we can draw this out. What's going on? So we have some text. Get white. Get bigger. And we are looking for a window. Which is this. Which, um, quickly target target this. And I think I'm looking at. Oh hey, dummy. Reach any milestone. Like you mean like work related or something? I think yeah, I guess it depends on what you mean by milestones. Let's see. I did I don't know. I've just been putting out a lot of resumes and stuff like that. I haven't gotten all the time. The market in Japan's pretty hard. I'm going to maybe start contemplating or working from US again. Just because like the pay difference is so drastic. You doing those keywords? Oh, which keywords? Like for this problem, you mean? Or you mean like when I'm doing job search? Let me pop out the chat. Too. Smaller. Uh, yeah, I'm not sure if my keywords are proper or not. I mean, I've mostly been applying to places directly. I've been using various search vectors. Um, it's like there's like some posting board stuff. Um, I've been using like AI to like help do job searches and both things down. Tried both like Cloud Code and I've done GPT like online stuff. The problem is just that I got paid quite well when I was looking at FAANG. So trying to find something that's not like a fifth of my pay scale in Japan is pretty hard because like just the way they pay engineers here is drastically different. Um, I don't mind taking like half my income or even less of that, but there's like a point where I have to start selling things. So I don't know. I don't know if my resume is as good as it could be. I've shown it to a few people and they say it's fine. So, and I've had AI analyze it and it says it's good. So I don't know. I'm mostly just not getting any callbacks at all. Like they either don't reply at all or they just instant rejection without a interview. So I'm not sure exactly what I'm doing wrong. I feel like if I was if I do decide to like switch to US market, just like work from the US, it seems like it'll be a lot easier. Um, both for pay scale and for just like abundance of positions. You have advice. Let's see. So I was working on this problem. Basically, you have to find each of these characters. Actually, like a comma for this. Like actually, each of these. I should be doing certs. I'm on school break. I kind of just relaxing instead of studying extra, but I've been working on some ideas to do my base programming on my learning app, the libx.io. Is this an app that you're making, or is this an app that you're using? Like, I don't know this app, lib libx. If you you're stuck on something, let me know. Um, happy to help debug. Also, I think that'd be the most fun thing is if like people actually brought coding problems to me, real world problems, and I help them solve it. That sounds fun. I don't know how many people are willing to like share their projects online, but it'd be cool. Okay, so basically we have to find all of these characters in some window inside of the safe stack. And well, by the way, Tony, if you want to join the Discord, this is on YouTube, right? There's like a huge delay on on YouTube. So if you want to do Discord, then I can see your messages faster. Actually, I guess text message. I guess it won't. That won't help. Actually, that what am I thinking? The text messages here show up instantly. Just the delay on the video, which that won't help with that. Okay, I'm sorry. Never mind. But if you ever want to talk offline, just Discord there. I'm trying to spend a bunch of time this week setting it up, so um, it's an option. Okay, so as usual, for solving these problems, um, the my first instinct is brute force, which is you would try a window that starts at every possible character. Um, I linked it at the top though. It's at the top of the chat. It's also put on screen, but unless you have a what's it called? Image to text or something. There's a name for that. I can't remember right now. Don't link is easy. You'll be my first member other than me if you join it, because I just made it this week. Uh, okay, so yeah, let's put up the brute force. Something like this. It'd be like this one. Let's talk about those two. This one, this one. Basically, just keep going. For each character, wherever possible. This would take a long time. Can I grab this? Do this right. For each character, start window, check. And then it would also be like, for each window, you have to check to see if you have all the target characters. For each window, check if all target. You can early out. This is the extremely slow but technically work method. Um, let's see if we can do better than that. There is apparently a O of M plus N, which means we're going to go through the haystack one character by one character, and we're going to go through the target characters one character by one character, and somehow get it. So only one path. I mean, you can do multiple paths, but somehow we're only checking each character once in each haystack. I'm saying once again, linear on both. And I'm thinking if we're going to do that, then we're probably keeping track of particular starts, right? Like, so, uh, at very least, any place that has one of the characters would be a window, right? So probably be going along, going, oh, A is in it, so that's potential start. When I see B, I'd be like, oh, that potential start can go to here. And then when we find the C, we can go to here. But also the B would be a potential spot. I don't know what we call this yet, like, check. So, 2 would be B, E, C, until we see the A, be like one window there. And there'd be another window when we start the C until we found the A. And there'd be this one. And theoretically, we would have started the A, but we never would have found the ending. And for this one, what's the actual B, A, M, C? Okay. B, A, M, C. Okay, so it is this one. This one at the very end that is the shortest. Yeah, that makes sense. That looks right. These are kind of hard to see. So it's super hard to see. Right. There we go. Hopefully that's easier to see. So it feels like this is, I don't know if this is quite, and like the thing I'm thinking is like I can, whenever I see a potential start, right, I find a character that matches, I can update all my previous matches, um, plus add a new one for the potential start, a new potential start, right? So when I see A, I would make one. When I see B, I'd be making a new potential start, and I'd be updating the previous A to, hey, we've got another character for you. The only thing that makes me hesitant with that um, is that technically O of n plus n because I'm also iterating over each of my potential matches, right? So if I had all A's in this list, then technically it'd be like, actually, what would it be like complexity? It'd be n n log n m. Like there's an m in there somewhere too, because I have to check it. Actually, also for each of these, I'm going to be checking to see if it's, well, okay, I'm assuming I'm putting my, I guess if I put my target characters into a map, this doesn't care about uh space complexity. If I put all my target characters into a map, then there's an n there, and then after that, it's just a constant lookup. Um, oh hey, is that you, Tony, that joined? Oh, this is a test testing user privileges. I didn't even notice Discord went. Gonna. Uh, so yeah, like I mean, this is the best idea I have so far. I'm gonna stick all these in a map so I can quickly look them up. Each one I find, I have like potential match. Um, when I find another character, I update the potential matches. I guess I would also have like a best match so I could like throw things away. Um, feels like each match has to keep track of like which character it's seen so far. So there's going to be a map for each. If I'm trying to keep this efficient, there's a map for each match. This feels like a lot of extra um, data to keep track of. Uh, my it feels reasonable as far as time complexity goes, but space complexity is going to get kind of crazy. Don't mention anything about that. Just trying to think if there's a better way to keep track of the data. I suppose you could keep a list of all this. Right, so um, keeping track of. Sorry, spelled that right. Another possibility is I just first find all the positions of each of the target characters. So it'd be like a pre-pass. So then that looks something like A, B, C. It'd be like find target positions. So then A would be at what? Index 0, 2, 0, 1, 2. Excuse me. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And B would at 0, 1, 2, 3, and that's 9. So it'd be, and then C would be at 4, 5, and 10, 11, 12. So I use this. And then potentially we could do some path over these. To find the start and the end. And then we'd have to take that substring. That feels pretty promising because there's like, but I don't know, there's still like a lot of combinations. It's gonna be, just trying to think through this. Like if we went down this path, there's gonna be A from 0 to 10. So we have to either include 0 or we have to include 10. It feels like this is not gonna be a single linear path though, because it's gonna be the ones closest to 0, right? As we start at 0 and the B's and C's close to 0 is 3 and 5, which means we have like a length of 5, just this one right here. Or technically length of 6. Did I do this right? 0, 1, 2, 3, 4, 5. Yeah, okay. Something's wrong here. 0, 1, 2, 3, 4, 5. Index is 5, C is 0. But if I go 0, if I minus the indexes, it's going to be length 5. I guess I have to just add 1 because we're including this character. Okay, sorry. B minus C is 2, but then it's actually 3 characters because we're including the last character. Okay, fine. So if I were to take the things closest to A, the other problem I'm going to have is sometimes test characters are like duplicate, right? Like there can be an A here. So if I just put them all into a map, that's not quite good enough. Because there can be, I think it said there can be including duplicates, right? So where was it? I thought they had an example here. So every character in T, including duplicates, is included in the window. Where did it? I swear to God, it somewhere explains that. Oh, it's the last one. Okay, TT is AA. So since it doesn't have two A's, so it's not going to be good enough to just like throw this into a map. Um, because like actually a lot of the like I think brute force would still work, but these ones still have this problem of when we see an A. Oh, maybe this one's okay because I could check things off, but you're still gonna have. I can't put this into a map. Getting to this N plus N feels very difficult. I have to have two A's. Oh, I guess it's fine. I guess you'd have like a okay, sorry. I still have a map, but I have like a count essentially for each one. Um, so I'd have if there was another A in here, then I would just have my map be A target is 2 and B is target 1 and C is target 1. So I just gotta keep track of. And then when I'm going through my list, when I see something, I can just stack from it. But I think this like find target position thing becomes a lot more difficult. It already feels like it's gonna be pretty complicated because I have to like try a bunch of different possible combinations of starts and ends to figure this out. So I think for now I'm gonna give up on this one. Um, so far this feels like the most fruitful as far as efficiency goes. Um, it's just a lot of extra data allocation. Um, it's possible that once I start, I will start seeing some rooms for optimizations. I feel like it's got to be something along this line. So because we need to when we're constraining ourselves to n plus n, then like we're going through this list one time, or maybe two times. So we're just starting at the beginning, going to the end. Um, and I don't see another way you could do it other than try to keep track of possible successes and then update them as we get new information. So I think I'm gonna go with that. If we go down that path, still readable on stream. I'm just gonna write some pseudocode here to like explain what we're gonna do. So first we need to create a map of target characters. Let's see. It's not even readable on stream. Um, Get a map of target characters and wired. And we need to go through each pair in haystack and we are going to if match or if is target character update all previous methods. Well, we're gonna create a new old temp Go match start update previous matches to this character or any like completed matches, meaning like we've satisfied all our target characters for that potential match. Pair about with best. Update best. If better than best match. Update. That's the basic idea. So cool. Now let's go about implementing this. Let's do for target equals app, and let's real quick learn how to I'm learning TypeScript, so let's like figure out how to declare type. Let's just do it here. TypeScript how to object. Yeah, they all false. Right, see. This, and it'll be a map of, yes, it'll be a match of string, the character to an object. Is it just a number for this part? I think it's just number count. If you wanted to get really fancy, we could define new types. So instead of it being string and number, it's more declarative. How do you describe how to types? How do I do this in Float? Yeah, like this. So like we do type string is equal, right? So we do character. Or target character. And then we could do count the number. Get super fancy here now. But this still, you can just check to see if it. Just want to check if the type's right. It's just that I'm not printing anything. Okay, cool. The cases are of course wrong, but it's wrong. So it's proper types. Okay. Message on Twitch. I need to figure out how to set up my filters properly. This Twitch. I was gonna figure out a better setup for how to quickly. I want to see all my chats, but then I have to get these windows, all these Chrome windows, like properly lined up. Sure, there's a better way to do this. Okay. don't know if I'm gonna get through this whole program today, but we'll see. Um, so target is, yeah, okay. We'll try it for each character. We are going to, if target, actually, so we could do is current count equals target characters. We'll get the character, and otherwise we will say it's 0. And then we will, and why is autocomplete not working? The set char to current count plus 1. And then we will, just so we can see if this works. This is just making our map. We're gonna split this. Split. We actually have an array instead of a string operating off of. Okay, so 1A, 1B, 1C. Actually, that's my 1A, 2A. Okay, sweet. Exactly what I wanted. Okay, now the next part is for each I don't know, I feel more GK doing for each for this. Honestly, this is kind of expensive too. Like, it might be better if I just did a for the. We'll see how far we are from everybody else's solution. I equals 0, I less than. I just go through the characters. If S I has, then it's a potential match. We can do something. Otherwise, we just keep going. We also need to keep track of our potential matches. We need to keep track of our best match too. So let best match equals this. That's actually what we're going to be returning at the end. Whatever we found as the best match. Let actually, maybe we should have it be null, so we know that when we don't have one, we just hang it, we just return this. Three characters. So if it's in, yeah, otherwise it's keep going. Oh, sorry. I forgot. We're gonna create the list of possible matches. I guess this is an array. Possible matches equals no, it's also type-based thing. It's just array in TypeScript. Array of object where we have a start, which is a number, and an end. Well, we don't need the end. We're like, where did it start? And then we have like remaining. Okay. We need to basically copy this. That's where like this is where I'm getting nervous about my head. Basically we're gonna keep track of where the possible match starts. Right. So for this one it'd be the 0 index, and for this it'd be the 3rd index and so forth. And then we keep track of how many more characters we need, which basically be us copying the target character map to start. And then as we find characters, we'll like pull stuff out of it. We'll reduce the number. And then once it gets to 0, we'll remove it. And then once remove the item from the list. And then once the map is empty, then we know we have a match and we compare it with our best match and see where we're at. Yeah. So if target character, we're going to create a new potential match. Push start equals I. Equal new map based on the previous map. Can I just do this to copy a map? I don't know if that works. I have to like turn this into an array from the. Just try real quick. Let foo. You guys even see this? I'm gonna pull this up. Let foo equal new map. Push set a to 1. And then we say the bar equal new map from bar. Oh, that worked. See, and if we add foo dot set e to 1, bar is not updated and set or foo is updated. Okay, that works. Let's see, remember APIs all the time. One, and then, well, like we have to pull out the character that we found, but I think since we already have to go do that for all the other ones, let's loop now. So possible matches that for each possible match, we're gonna do something. This too. What do we gotta do? We have, actually, let's use a little trick here to pull out all the values instead of this. Let's start and remaining characters. So if the main characters has, I should probably just like call this uh, uh, haystack character. Equals S of A I. Do S of I everywhere. So if it has that thing, then we need to separate. We need to reduce it. Count equals count reduced if count is 0, then let's delete it out of the thing. Delete or is there remove? Guess we'll find out if that's the wrong syntax. Otherwise, we need to like update it. If we're removing a character, we've gotten to 0, something like that potentially means we've completed a match. And then so if size, I don't remember the syntax. Oh, I'm just gonna get syntax errors. All these and will go update them. I'm not sure what size or count or what, but if it is 0, then that means if we removed it and now there's no more, that means we've finished our match. We found a match. At which point we want to go if start plus I, well, first if best match equals null, or best match dot length is greater than I, or I guess, yeah, I minus start plus 1. Right? We're starting at 5, or we started at 0, and we've got a character at 5, at index 5, then the length is 6. All right, so if it's one of these, space, if it's better than the best match, that's what this check is. Update the best match. And now we need to figure out how to properly do substrings API. But that match is going to equal our input string s dot or something start to I. But now I need to go look up what the APIs are like. JS strings, so string. 1 to 3 would be 0, 1, 2. So okay, so you won't. It's going to take one more. This is the doesn't include 3 basically. 0, 1, 2. So I want start plus I plus 1. Okay. I mean, that's a good place to start testing, I guess. Let's see how many syntax errors I have. That it's probably 10. All 2. This is supposed to be a comma, so it's semicolon. And assign count. Oh, count is constant. Whoops. Remove. Yeah, so like how is it deletes? I think it's maybe delete. Yeah, map. It is delete. That was my first instinct too. I'll see, even after 15 years, still can't remember. Oh, hey, I'm missing my. Is it? I'm missing my little thing that says it. 15-year thing. There we go. Any bigger? Sorry, I get easily distracted. Okay, this expression is not callable. Yeah, I meant, what was the thing? Substring for substring, whatever that guy did. And then get length of images. Is it just size? It's the property, it's not a function. Okay. Yeah, my point was, doesn't matter how long you've been doing this, you remembering all these APIs is hard. Okay, sweet. So we passed their test cases. So I guess let's try somebody and see how bad pair. Run in. All right, time limit exceeded. Okay, sweet. So let's add that test case. How do you wait? I thought there was a way to add a test case easily here. Oh, use test case again. See, now there's a plus. Where was it? So super long S string and super crazy T string. Yeah, so this is what I was worried about, which was that I don't like. So although we're looping through, this is essentially looping through the T string ones, and this is looping through the S string ones. The possible matches gets ever larger, and we're looping through each of those. So it's not technically n plus n. Potential, like, I think it's wait, which one's n, which is the yeah, it's like m, it's n plus m log n, I think. I could be wrong on that. Don't quote me on that. Or is it n factorial? It's not factorial, right? I don't know. That'd be worse. I think it's log. It's log m whenever it's m and then m minus 1 and then m minus 2 and then m minus 2, right? Like, and I think that's what I have, where basically if I'm never completing these things out, I just have to like keep adding. So this basically this is my biggest problem. It's like keeping this thing. It's also my biggest memory problem, right? Because like I'm for each one of these matches, I'm creating a whole nother map. Which honestly, actually, just that this copy is probably copy is another loop over m. So now we're talking like M times N for each match too. So yeah, all kinds of bad. Um, it does feel like it does feel like it's working. It's not as efficient. So we got to find a different way of dealing with this. Hopefully, it's not a completely different approach. It's just a different way of storing these. Um, just trying to think. I need some way of checking off. Sorry, just thinking. Just think all. Um, if we like, there's two ways I want to go, which is one is can I somehow collapse possible matches, right? So if I've got some sort of start already and I find another character, do I always have to create one? But I think possibly yes, because if there had been a big lead up to the next character, and then there's another one of these like big lead, the character that started the big lead right at the end, right after I find the other characters, then I need to keep track of that. There's still something like along this lines that like is calling out to me. Let's see if I can draw this out. Like what I'm saying here is this. It isn't the play. No, it's not. Never gonna line this up already. Almost. Not that bad. I don't even know what I'm trying to draw here. This feels like there's like a it's five. So I'm just kind of curious in this thing. It's just because it's like such a random string. There's just like too many characters. Yeah. I don't know. I'm running out of time. Running out of time. I this is exactly the sort of thing where I mean, I guess if I was in an interview, then I wouldn't be able to do this. But if this was normal coding, I'd probably like take a break here and do on it while I'm doing other stuff. Um, where I'd like lay down and let my brain go through all the like combinatorial possibilities. Um, if I was in an interview, then I would be showing off these ideas, and oftentimes the interview will like give you a little bit of guidance. They'll like help you point you in the right direction. Um, they'll help you save time, but like dissuading you from like dead ends. Um, but at this point, I need to think about a lot of possibilities, and I don't have a lot of time because I gotta get off stream. I just feel bad because like then if I end up thinking about this off, I'm gonna solve it off stream. Um, gotta be a better way too. Um, the problem with this test case is basically that we're never able to um, reject any of the possibilities, right? Like presumably this has every letter in the alphabet in it below, which I'm just gonna make an assumption, but it could have every possible letter in the alphabet. And so for every single one of these characters, we have a new potential start. And um, since there's so many characters, or the like the character lengths are similar, we're also never able to finish uh like finish this possible. So we don't figure out where this potential start ends. Um, and so we're forever holding on to the hope that maybe this will be the start. And then we do the same thing with the next character, and the same thing with the next character. Um, and so we have an ever growing list of potential starts. Um, we're still constrained to, well, it's a pretty big string, but we're constrained by the string size. But yeah, if we have to keep going back through each one. I guess I could make this a reverse lookup. So what I mean by that is right now I've got a list of partial matches, um, and a list of remaining characters. If what we had was a list of, for each list of character, we had a list of um, people looking for that character. Then whenever we got a new character, we would just go and be like, hey, everybody who's looking for this character, like you're good. Um, I guess the problem is like, so once I so each possible match would basically put itself into a character saying like, hey, I need X of these. Um, but even then, when I put it in, I'm gonna need to go through. That's gonna still be M times N, because like that means for each of these, I need to stick myself into every possible character that I might be a match for. Um, maybe we could get around that by instead feeling your. Well, I'll just put that pin in that for a second. Um, but yeah, if we had for each character, we knew who we possible, if we knew all the possible matches that might be satisfied by having done this character. That would save us a lot of time. But yeah, just knowing it makes knowing when the match is done a lot harder, right? Um, I mean, if I'm really not caring about memory, I would still have the possible match be this structure, but just instead of it being an array, it'd be a map and it'd be inserted in each one. But it's gonna be and still gonna be pretty expensive because that means for every character, for every test character, we've got to like stick it in there. It's just that's very unsatisfying. Not good. But I still feel like this is worth exploring a little bit. Okay, I'm gonna time myself at 10:30 my time. Okay, trying to reword the problem. For whenever we get a new character, what we need to do is figure out if that completes a window, and if so, we need to check it against our best match and update it. In order to know if it completes a window, if we need to do it we basically need to do it in constant time, right? Like we've spent since we're trying to do this in O of m plus n, we need to we've spent our m here. Right, and then we're going through this n, and then basically this needs to be constant time. So we'd have to be able to oh, you know what? I just had an idea. Right, new idea. Should I put this? New idea. Moving window. The way this would work is we would keep each time we found a character, we'd be moving our window until we found a match. Right? How can I explain this? So we'd be looking for A, and then we'd looking for B, and then we'd be looking for a C. We keep like trying to update our best match with each new character. Once we found a match, well then we need to find our another one of the left hand sides, the whatever our character is at the start. We have to find the next one up to be able to move our window. So the next possible match would be the next A. Okay. Oops, I don't want to get rid of the other one. I want to copy that. So like the first one found and we found the A, we found the B, we found the C. Cool, we got all of our matches. The first part of our job is done. Which is that we found a window. It may not be the best window, but we found a window. Then in order to find another window, it's going to be looking for the next. We need to, in order to find another window, we need to get rid of we take out the A, the first one of our window. Well, then we're going to need another A somewhere else. So uh, we're moving until we get to the next A, right? So I wish it was easier to do 3-point stuff, but maybe there's a way, and I just don't know. So we need to find another A. So the next A is there, and then we got another window, but this window is not better than our existing window. So we're gonna still keep track of the best one. But in order to find another window beyond this, we'd have to get rid of the next B. That poses a problem. The next best B is actually here. It's not at the end. So you can't keep. If we've got like two cursors, we need to move the left one. This breaks my brain a bit. So what I want to be the next move is it's gonna go. It should find this one, right? So there's a question of how we find this one because we need it. It's not. We got rid of the A. And I'm assuming this has to be a stack of characters because we need to know that we can go to the B. So we're gonna get rid of the intermediate step here, right? Which is we get rid of the A and then our next thing is here, but we're missing this is not a proper match, right? Well, let's change this color too. Right, this is we find a match and then we go, okay, cool. So what's the next one? We get rid of the A, which pulls us to here. And then like, well, we don't have an A, so we keep going until we find one. But for this one, we pop the B, right? And we would go down to I guess we pop the B and we would go down to the C. But then we would think we need to keep looking for we would think we were in a bad state to get rid of the B and go, oh, we need to find another B. But we actually have a surplus of Bs already inside of us. So this is actually already a possible match. And we need to like know that somehow. And we need to know that in constant time. Um I think this is gonna be the right. This feels like way better. This feels like this is on the right track. I just need to figure out how we decide upside the left hand side of our window and the right hand side of our window. Um, like I could keep track. I could still have the map of like characters that need to be found. Um, and then like we'd have like negative numbers for like we've got a surplus or something. But the problem with that is I need to know when I've got all the characters, when I'm done. Um, and if I've got all these surplus things, well then I'll have to like go searching for. I guess I could keep two maps. Like I'm just thinking like it's really nice if I've got like this map that I'm like reducing things out and then it gets to zero and I'm like, sweet, I'm good. Um, I guess if I keep another map that is my surpluses, um, then when I remove a character, if there's a surplus for that character, then I would reduce my surplus of that, and I'd be able to go to the next one and consider this done. Um, I guess that would work. And then when I go searching for the character that I need, I would also bump my surpluses. Okay, I don't know if any of that was coherent, but basically what we're gonna have is we're gonna have one map that is like essentially our missing characters, and we're gonna move the right hand side of our window um, until we until we found all the characters that we need. Once the required characters goes to 0. Anytime we have a character um, that is a target character, but it's not in our required list, well then we're gonna add it to our surplus list. It's like, oh, we've got a surplus of this character. And we're gonna keep doing that until we get to 0, which would be this one right here. Then what we do is we take the first character of that, we pop it, and we're also gonna need like this is gonna be um all the characters that we find. I think we need to keep inside of a list that we can uh it's like a queue of characters, right? So we're basically adding A and then B and then C as our queue. We're gonna take the A off, which would get us down to B, and each of those characters have to keep their indexes so that we know. So we're gonna get rid of the A, and we're gonna say, okay, cool. Since we got rid of an A, we need an we put an A back into our required list, and now we can well, we take the A, we first check in our surplus. If we've got the surplus, then we're good. This is another match. If we don't have it in the surplus, we add it to our required, and now we need to start moving the right hand cursor until we find the missing character. And then I think we have to keep going until we pop a character and there's no more surpluses and we can't go further right anymore, and then we're done. Okay, I think that's right. I think this is the right idea. I just need to code it up now. I need to end stream, do my workout. Uh, but yeah, I think this is good. Fun problem. Thanks for joining. Join Discord. That was great. I'll see you guys next time.